Hello, everybody. Today we have a kind of special lecture for you. I'm here in the studio of Delft University in the Netherlands, and today I'm doing a short interview with Eran Karmel, and he's in Washington, D.C. in the USA. Hello, Eran. Thank you for joining us in the MOOC today. Please, could you tell a little bit about yourself to us?
Yeah, good morning from here from Washington, D.C., 6 time zones away from you. I'm Eran Karmel. I'm a professor of information technology at the Kogod School of Business at the American University here in Washington, D.C. I'm 6 kilometers away from the White House.
Okay. You're one of the founding fathers of the research on global software engineering. Can you tell us a little bit about what did it all start with? How were you inspired for this research?
Yeah, so I've been researching global software engineering and global software and global work for about 20 years now, and I have written quite a few articles and books about this topic. And let me take you back to the early days, if you will. I began researching this and thinking about this in this context. In the early 1990s, let's talk about where we were in global software engineering. We had a few large tech companies like IBM and the number 2 computer company at the time, Digital Equipment Corporation, DEC. They were doing very rudimentary global software engineering. They were working internally on internal networks. They had very primitive email by today's standards. When they had to transfer a software program, they actually transferred it on tape via Federal Express, so it took 2 or 3 days to arrive. They used faxes, and there were no cell phones back then. And then when I began studying this, there was a big shift. It was the late 1990s. The internet suddenly took off, and all the high-tech companies at this point had access to the internet, and they were able to do email. But we only had a little bit of instant messaging at the time. There was no voice over IP. There was no Skype. There was no video. There were very few cell phones still at that time. And that's the point where I began studying global software engineering. In 1995, one of my students who worked here for one of the software companies here did a small report in a class of mine that I found extremely interesting. And she talked about a project in their company that was working with an offshore group in India, and they were figuring out how to manage that. And as a result, I began studying global software engineering, and I began visiting with companies around the world, and that led to my first book, Global Software Teams, which came out in 1999. Which was, in hindsight, a milestone in our understanding of global software engineering. I visited with quite a few firms. I interviewed many by phone. And in that time period, one of the interesting milestones was the first IBM effort, serious IBM effort at global software engineering in this new era of the internet. And let me read you the press release from 1997 from IBM. This is February of 1997, so it's 20 years ago now when I'm taping this interview here. And it says, IBM goes on a 24-hour-a-day cycle to speed Java application development. Highly skilled software developers in Belarus, in China, in India, in Latvia, and in the US are working on a virtual team to create Java beans. So what we have here are 5 teams spread out by IBM across its sites across the world. And the intent was to pass on the work every day as the teams go home and have another team continue working on it as they pick it up and they begin their work day. So that's the context that I began studying software engineering.
Okay. So, and did a lot of things change since then, Eran? Because I was intrigued about the countries you mentioned in the article are still the same at this moment for a number.
Yeah, so I'll come back to the IBM story towards the end. I think that's an interesting first attempt at global software engineering. But so now let's understand where we are now, 20 years later. Our structures from the 1990s are somewhat similar. We still have a lot of global software engineering efforts. Some of the people are working in a clustered environment. They're working in a team room or in a co-located office, and some people are working solo by themselves and collaborating. So these structures are somewhat similar. And 20 years ago, we identified 5 global fault lines, lines as in problem lines. And they are language, culture, time, distance, that's geographic distance, and organizational. And all those fault lines still exist today. They are almost as difficult today, 20 years later, as they were in the late 1990s. And let me remind you that I think with an interesting anecdote of how we haven't come as far as we sometimes tell ourselves. Today in Silicon Valley, in the center of global technology, one of the most important companies in the world, Google, every day, thousands of its software engineers get on buses in San Francisco and commute down the very congested Highway 101 from San Francisco to Mountain View in Silicon Valley in order to work in a co-located space at Google headquarters, at the Googleplex. So this means that even a company like Google, with its very selective software engineers, feels that it's important that everybody spend the time to get to one location and work together. And so we're still facing these kind of problems of working over distance that we began to identify 20 years ago.
Okay. And one other line of your research is on time and temporal distance, so to say. What did your research on time difference teach you?
Yeah, so about more than 10 years ago, I got together with my colleague here at American University, with Alberto Espinosa, and we identified one part of the global software engineering landscape that we thought was particularly important, and that's the time zone differences. So we dove into researching that, and that led to our book that came out a few years ago. I'm working while they're sleeping, I should say, and time zone separation challenges and solutions. So that came out a few years ago. Now, so I'll tell you more about that, but let me give you the context a little bit. In the late 1990s, somebody wrote a book called Distance is Dead, and that meme became important for many people in understanding this new area of global technology. But although distance is dead, we can now communicate very easily, like I'm communicating with you now. Temporal distance, which is a fancy English word for time, is certainly not dead. And all of the technology that we have hasn't mitigated the issues of time. So you are in the Netherlands now, and you are 9,000 kilometers away from both South Africa and Los Angeles. So you're equal distance from both locations, but the difference in time zone is extreme. You're only one time zone away from South Africa typically, and you're 8 time zones away from Los Angeles. That's a big difference, and that really affects how your project works. So we haven't mitigated that, and no amount of our current technology has addressed that. And I'm going to do something a little bit unusual here. I'm going to give everybody who's listening a small quiz. You ready for the quiz? Okay, so jot down your thoughts on this. Something that I always do with my listeners, because time zones is something that they are aware of, certainly, but don't follow as much as I have. And so let me ask you about the big countries in tech. How many time zones are there in the United States, in the lower 48 without Alaska and Hawaii? Think about that for a second. How many time zones are there in China? How many time zones are there in Russia? And how many time zones are there in India? Okay, did you write down your answers yet? Okay, so let me tell you. There are 4 in the United States, here in the Eastern time zone of the United States in Washington, D.C. There's 1 in China, only 1 in that big country, and that's because 60 years ago, 70 years ago, during the revolution, Mao Zedong decided that time zones were for capitalists, so he threw them away. There are 10 time zones in Russia. There used to be 11, and there's only 1 in India. And there's ongoing discussion about splitting India into 2 or even 3 time zones, but that hasn't been done yet.
Okay. I didn't know that the facts about the time zones. It's interesting to hear that story. I will dive into it myself certainly. I've one question about it's about hurdles on time zones and temporal distances. What's the biggest hurdle you discovered when investigating time zones and temporal distance?
So from our research specifically on time zones and on time separation, we found that there were 2 immovable factors that were at loggerheads with one another about working across time zones in global software engineering. So on one hand, humans have a 24-hour circadian rhythm, and we are wedded to that circadian rhythm. Scientists have researched this for many years, tried to move us away, but we're on a 24-hour cycle. And number 2, very closely connected, we like to work during the day and sleep during the night. And I know those of you who are students, you are laughing at me and saying, oh, that's not necessarily true. But I think that if you look around the world, the evidence is very strong that except for students, the rest of the world works during the day and sleeps during the night, and not vice versa. Now, on the other side, we know from human interaction that when we're talking about complex tasks, there is a need to converge in real time between human beings. And there's 2 types of complex tasks that I talk about. One is creativity and ideas, and the other is disagreements. So both of them are highly complex in terms of our human interaction, and they require us to interact in real time, not in asynchronous time, but in real time. And that requires real-time communication. Now, it doesn't have to be face-to-face. It can be across distance like I'm doing with you right now, but it does require real-time communication. So restating the fundamental problem that our time zones, we have to create overlap time slots to negotiate convergence on ideas and convergence on disagreements. That is the fundamental issue. Technology has not touched that, not even a little bit. Now, let me add one more thing, is that in addition to time zone separation, like you and I have now, in work environments, there are other kinds of time differences that affect our ability to coordinate, and they are different work hours. Americans work 9 to 5, Spaniards work 9 to 7 because they take a longer lunch break. Lunch breaks are different, in fact. Weekends are different. The Christian world has weekends of Saturday and Sunday, but the Muslim and Jewish world does not. Holidays are different. The Christian world has Christmas. In India, they do Diwali. Vacations are different. The Dutch and the French take long vacations. The Americans take short vacations. And then we have the equatorial distance between North and South Hemisphere. The rhythm of the North is very different than the rhythm of the South because of the academic year. We slow down in our summer in the Northern Hemisphere and vice versa in the Southern Hemisphere.
Okay. And if you look at technology in that part, what will be the role of technology when dealing with time differences in a global software engineering setting?
So I've looked at again at some of the technologies in the recent years, and we have some very nice new technologies for collaboration, including one of the ones that's very popular here in the U.S. called Slack. So these are nice technologies, but none of them really are affecting the fundamental problem in global software engineering of working across time zones. So technology hasn't really addressed this problem yet. I think that we will at the end of the 21st century, well before the end of the 21st century, when we don't have to sleep anymore. But that's a long time away.
Okay. Well, I know Slack. We're using it in our university as well, and I agree. I agree with you that it's solving some issues, but not all. So if it's not technology, what will be the main differentiator? Do you think?
So the dirty little secret that we discovered as we were researching how global software engineering was conducted all around the world is that the dirty little secret of solving it was not technological at all. It was time shifting. Time shifting is when workers adjust their working hours, creating an overlap window between them. And the overlap window can be a specially planned overlap window that happens maybe every day, or it happens once a week, or it can be an ad hoc one where you just have to do a coordination and let's say in the Netherlands, you say, okay, I'll meet you over Skype at 10 o'clock after we have dinner and we put the kids to sleep. Those acts of time shifting are the key solution to coordination across time zones. Now, who does this time shifting? What we discovered is that not necessarily everybody does that. In some teams, it does happen that everybody has to time shift, but usually the case is that we have what's called a temporal liaison. In other words, one or a couple of people who do this connection across distant sites. And it might be a team lead or a project manager. And now contrast that with another kind of global work, which is the call centers in the Philippines or India, who work with U.S. customers, and there everybody time shifts. Most people there work at night in the Philippines and India to correspond to the American sunlight hours. Now, as a result of this dirty little secret, the need for time shifting, let me introduce you to three terms. The three terms are nomadism, scatter time, and time shifting. So nomadism comes from nomad, to be working any place. And so the people in nomadism, and nomadism is about place, it's about geography, can be working any place that they want, at a cafe, at a restaurant, at a hotel, and so on. The next two terms are about working across time zones, and they are scatter time, which is a term that we introduced in our book. That's when you, as an individual, you spread out your work across the workday. So you might wake up and do a few hours of work, and then you might take the kids to school, and so on throughout the day and into the evening. This is how many people actually work that we found. Related to that is time shifting, when workers adjust their working hours deliberately to create an overlap window with somebody who's far away in terms of time zones. And so those are the three terms: nomadism, scatter time, and time shifting.
Okay. And what did you discover about time shifting? What are the pitfalls, the do's and the don'ts?
So what we discovered is that time shifting is rampant in global software engineering. In every single software project that we studied, we found at least some time shifting. And in some, of course, we found a lot. The related issue that's not surprising is that scatter time is practiced a lot. There's evening work, there's weekend work, and that happens a great deal. It varies by country. Related is that we actually don't know enough about how this is practiced. So our study looked at some teams, but a much more comprehensive study, as far as we know, has not been done. A couple of years ago, I found a nice study that compared French and Norwegian software engineers, and one of its findings is that there's some different approaches to scatter time that they have. The French software engineers like to stay late at work at the office, but then once they go home and they don't telework at all. In contrast, the Norwegians did the opposite. They went home at a normal time, and then they did a few hours of work later on at home. So there's some clear cultural and labor issues. What we also know about working about time shifting is the need for night work. And so there's quite a lot of research about working the night shift and working a lot at night. And the news isn't good about that. Night work is terrible for your health, and it's terrible for your family. If we're talking about physical issues, it leads to poor sleep, it leads to poor reproductive health, it leads to diabetes and possibly weight gain, and it increases the incidence of some cancers. In terms of its effect on the mind, it leads to stress and depression and fatigue and loss of empathy. It increases family stress. It leads to accidents. Many of the great industrial accidents happen because of night work. So we know this from the study of half a century and more of night shift and of workers who work at night. We haven't seen this yet in this new age of global software engineering. We don't have these kind of comprehensive studies, so we don't know what kind of impact it's making.
Okay. So were there more interesting or surprising results in your research on temporal distance?
Yeah, I'll tell you two stories. One is that we discovered that there was a little bit of competition vis-a-vis time zones. So when I first started going to India in the early 2000s, I heard the Indians thumping their chest and saying, "We have the best time zone in the world." Why? Well, we here can work while you in America are sleeping, so we have the best time zone. And then some years later, when I started going to Brazil, I also heard them say, "We have the best time zone in the world." Why? Well, we have a similar time zone to you in North America, so we can work while you are working. And so everybody thinks that they're in the best time zone. We encountered one company that had a very interesting approach, a very rigid engineering approach to addressing issues of distance and time zone separation. And we labeled this approach as real-time simulated co-location. And what does that mean? Well, first of all, they addressed the temporal distance, the time distance, by deliberately shifting one of the teams to work on the other team's time zone. So if they were 2 time zones apart, then one team had to begin their work every single day, 2 hours a little bit later than normal. So they addressed the time zone separation issue that way. And of course, everybody had to go to lunch at the same hours. They addressed the geographic distance by putting a huge screen on their team rooms in both locations with an always-on video and audio so that you can always see what's happening on the other team site. And you can walk over to the microphone and call Joe over there in the other team room and have a quick chat with him. And so they address this issue of distance, at least to some extent, with that technological solution.
Okay, I've seen that solution working in many companies, and I agree with you that it's to a certain extent it can help a lot with teams. Just a final question on this holy grail in global software engineering and follow the sun. What's your take on follow the sun? Will we ever get it working? Will we see real follow the sun software engineering, or is it more a promise that might never become reality?
Yeah, so follow the sun is a great term, isn't it? It's so evocative. It sounds so sexy, right? We've heard about follow the sun for 20 years. And in fact, that IBM project that I told you about at the beginning of our interview was called the Follow the Sun project. So it really captured the imagination of so many people in the beginning of the era of globalization of the 1990s. But the core of Follow the Sun is that you're handing off your work at the end of your workday to the next team many time zones away so that they can keep on working. And so the core idea is that you're collapsing the time to finish the project or the time to market. And that's really what's interesting here. It's not that there are many teams working on something. So in order to do that in software engineering, and this is what IBM attempted to do in 1997, you are handing off software programs that are unfinished to the next team several time zones away. And you're doing this every single day. Now, those of you who are programmers presumably most of the listeners here are programmers, you know that it's very difficult to do that. It's very difficult to coordinate that and give a piece of half-finished work to somebody else and then go leave work and go to sleep. And so IBM tried to do it every day. And what they discovered, remember that they had 5 sites in that original structure. What they discovered immediately is that doesn't work. And so they reduced it to 1 or 2 handoffs a day. And even that was essentially didn't work for them. So they quickly split up their work in a different way. And they did not practice follow the sun. So after that, in my many years of visiting various software organizations around the world, I always looked for instances of follow the sun. And what I found is basically that no one does follow the sun. No one hands off unfinished work on a daily basis to another team elsewhere. And that's because of the coordination required and because of the need for convergence on so many critical things. Now that's different from another mode of global work, which is global help centers. Global help, technical centers, help desk, tier 1 support, and so on. What they do is they have people working during normal shifts and then handing over the work to a center somewhere else in another time zone. And that's because they work on tasks which typically last 5 to 10 to 30 minutes, and they don't have to hand off and coordinate very much. They start a task and they finish it very quickly. They open the ticket, they close the ticket, and all that happens quickly. There's very little to hand off at the end of their day, sometimes nothing to hand off at the end of their day. So those centers, and we've seen, of course, a lot of them, some of you might be working in a center like that. Those are quite common, and we call that round the clock. So I distinguish between round the clock and follow the sun. Follow the sun is very difficult and very rare. Round the clock does take advantage of time separation and is quite common.
All right, Eran, thanks a lot for your interview and the great stories you told us about global software engineering. Well, again, thanks a lot.
Thank you.